Hello everyone. Today we will see design of slab base. First of all, we will see design steps of slab base. First step, assume a suitable grade of concrete. Second step, write down the properties of given section by using steel table. We need 4 factors only: TW, H, BF, TF. TW thickness of web, H is the depth of section, BF width of flange, TF thickness of flange. Okay, so next step third, find bearing strength of concrete. So bearing strength is given by formula 0.45 FCK, where FCK is characteristic strength of concrete. Step fourth, find area of base plate. So area of base plate is given by formula A is equal to P divided by bearing strength of concrete. Next step fifth, find length and width of base plate. Suppose this is the base plate having width of base plate B and length of base plate is L, and this is the I section. So I section having, this is the depth of I section H. Okay, so how to calculate length and width of base plate? L is equal to H plus 2A, B is equal to BF plus 2B. First of all, L is equal to H plus 2A. This A1 and this is second. So L is equal to H plus A means H plus 2A, and capital B is equal to BF means width of flange plus small b, this portion and this portion, B plus B 2B, so BF plus 2B. Okay, and A is equal to L into B. A is equal to area of base plate L into B. So what is the value of L? H plus 2A. And what is the value of B? BF plus 2B. So BF plus 2B. So next, step 6, find provide area. Provide area A dash is equal to L into B. Step 7th, the intensity of pressure W for concrete pedestal. So W is equal to P divided by A dash. P is the factored axial compressive load divided by A dash is the provided area. So W is less than 0.45 FCK. Therefore it is satisfied. Okay, so next step 8, find thickness of slab. How to calculate thickness of slab? So TS is equal to square root 2.5 into W into in bracket A square minus 0.3 B square into gamma MO divided by Fy. This is the formula, and the whole term TS is greater than TF, means thickness of slab is greater than TF, means thickness of slab should be greater than TF. Okay, so these are the design steps of slab base. Next point, we will see the numericals on design of slab base. Numerical first numerical, design a slab base for a column ISHB 400 at the rate 82.2 kg per meter subjected to factored axial compressive load of 2000 kN if the load is transferred to the base plate by direct bearing of column flanges. Use grade of steel Fe410 and grade of concrete M20. Firstly, see the question. Design a slab base for a column ISHB 400. Means depth of section is 400 at the rate 82.2. It is the self weight of this section. 82.2 is the self weight of this section, which are subjected to factored axial compressive load, means P is equal to 2000 kilonewton. And if the load is transferred to the base plate by direct bearing of column flange, use grade of steel Fe410, means Fy is equal to 410 Newton per mm square, and grade of concrete is M20, means 20 is the FCK. Okay, first of all, write given data for this question. Given data, given section is ISHB 400, 82.2. Factored load is P is equal to 2000 kilonewton. So 2000 into 10 cube Newton, multiply by 10 cube, convert kilonewton to Newton, multiply by 10 cube. Then grade of steel Fe415. So we can write Fy is equal to 410 Newton per mm square. Then grade of concrete M20. So we can write FCK is equal to 20 Newton per mm square. Step 1. Assume suitable grade of concrete, but if already given, so write down given value. FCK is equal to 20 Newton per mm square, already given value. Then second step, write sectional properties. In given question, given section is ISHB 400 at the rate 82.2. So given section is here ISHB 400. So write sectional properties by using steel table page number 14. Okay. So write down this value H, BF, TF and TW. Here in step second, write down sectional properties for a given section ISHB 400 by using steel table page number 14. See this steel table, this is the, so we need some factors like H, BF, width of flange, thickness of flange and thickness of web. Okay, so we need 4 factors only for the designing of slab base. So depth of section H, width of flange, thickness of flange and thickness of web. For the section ISHB 400 is here. Second part ISHB, its self weight is the 82.2. So second line, bottom third line ISHB 400. So depth of section is here 250. So H is equal to, depth of section is 400, H is equal to 400. Then second is the 250, last third line. BF is equal to 250. Then thickness of flange 12.7. Then thickness of web 10.6. So depth of section H is equal to 400, then BF 250, then TF 12.7 and then TW 10.6. Okay, so these are the values of section ISHB 400. H is equal to 400 mm, BF is equal to 250 mm, and TF is equal to 12.7 mm, then TW 10.6 mm as per steel table. Okay, then third step is find bearing strength of concrete. Find bearing strength of concrete. So bearing strength of concrete is equal to 0.45 FCK as per IS code. So 0.45, put the value of FCK. FCK is 20. Then we get 9 Newton per mm square. So bearing strength of concrete is 9 Newton per mm square. Then step 4th, find area of base plate. Area of base plate is calculated by formula A is equal to factored load divided by bearing strength of concrete divided by bearing strength of concrete. Okay, so area of base plate, put the value in this above formula. Area of base plate is equal to factored load divided by bearing strength of concrete. So factored load is given 2000 kilonewton. Convert Newton, so multiply by 10 cube. So 2000 into 10 cube divided by 9. 9 is the bearing strength of concrete as per step 3rd. So area is equal to 20. Solve this equation, then we get A is equal to 22.22 into 10 to the power 4 mm square. Then next step 5th, find length and width of base plate. Find length and width of base plate. Now find length and width of base plate. We know that area of base plate is equal to L into B. So if L is equal to H plus 2A and B is equal to BF plus 2B. Okay, so area is equal to L into B. So L is the H plus 2A and B is the BF plus 2B. But A and B are unknown factors. A and B are unknown factors. Therefore, we assume A is equal to B. Assume A is equal to B. For calculating unknown factor, so put the value of A, H and BF and put the value of A and B is equal to X. We consider A and B is equal to X. So put all the values in this equation, then we get what is the value of A, area. What is the value of area? So A is equal to 22.10 to the power 4. This is the area of base plate as per step 4th. Is equal to, what is the value of H? 400. H is equal to 400 as per step 2nd plus 2 into, we consider the value of A is X into BF is equal to 250 as per step 2nd plus 2 into B is equal to X as per step 2nd. So A is equal to B is equal to X value, right? A is equal to B is equal to X value. So solve this equation, then we get X value. Okay, So x is equal to 76.15 mm. Make it round off. So 80 mm. So A is equal to B is equal to 80 mm. Right? Find L and B. Find L and B means length and width of base plate. So L is calculated by formula H. L is equal to H plus 2A. L is equal to H plus 2A. So put the value of H and A. So L is equal to H. What is the value of H? 400 as per step second, plus 2 into what is the value of A? 80. Then we get L is equal to 560 mm. Okay, L is equal to 560 mm. So second, width of base plate. So width of base plate is given by formula B is equal to BF plus 2B. So B is equal to BF. What is the value of BF? 250 as per step second, plus 2 into B, small b, 2 into 80 mm. Small b is the 80. Small b is the 80. Then we get B is equal to 410 mm. 410 mm. Okay. Next step, step 6th. Find provided area. Find provided area. So provided area is denoted by A dash. A dash is equal to L into B. So A dash is equal to L is the, what is the value of L? 560. So 560 into B, 410. So A dash is equal to 22.96 into 10 to the power 4 mm square. So A dash is equal to 22.96 into 10 to the power 4 mm square. Next step, step 7th. Find intensity of pressure for concrete pedestal. So it is denoted by W, and formula W is equal to P divided by A dash, and which is less than 0.45 FCK. So W is equal to, put the value of P and A dash, then we get W is equal to 8.71, so which is less than 9. So condition is satisfied, hence okay. Okay. So next step, step 8, find thickness of slab. Find thickness of slab or thickness of base plate, which is denoted by TS, and TS is calculated by formula TS is equal to square root 2.5 into W into A square minus 0.3 B square into gamma MO divided by Fy. Here gamma MO is equal to 1.1 as per IS code. So TS is equal to 2.5 into, what is the value of W? W is the 8.71 into, what is the value of A? A is the 80 and B is also 80. So 0.3 into 80 square into gamma MO 1.1 and Fy is given 410. Okay, then we get TS is equal to 16.17, so which is greater than TF. Hence the condition is satisfied. TS is greater than TF means 16.17 is greater than TF is given as per step second 12.7 mm. Hence okay. So this condition is satisfied. So it is clear that as the load is transferred to the base plate by direct bearing and there is no bending moment, so there is no need to design of connection. Okay, thank you.